The rise of cryptocurrencies like Bitcoin and Ethereum has led to amazing things. We can now send money with complete security, write smart contracts so that we don't have to employ a notary or lawyer, and much more. Ethereum is a blockchain application that not only has a cryptocurrency, Ether, but also allows you to code on the Ethereum blockchain or some testnets so that you don't have to spend actual money. The code you write is known as a smart contract. You can even code actual apps on the blockchain. These are known as decentralized applications, or dApps. There are a lot of dApps you can write on the blockchain. A notable dApp is Bitcoin, as it is a decentralized banking application on the blockchain. I recently coded a dApp myself, a voting application, and used some tools from Truffle. Truffle is a set of developer tools that enable me to test and run my dApp. If you're thinking about getting into the blockchain space at this time, I highly recommend learning about Truffle. I used the Truffle Pet Shop template and reconfigured it to work as a voting application. We start with the Solidity version 0.4.2. From there, the contract election is created. This is the actual smart contract. Within the smart contract are a bunch of functions to create candidates and add votes to the candidates. The first thing to do is define what a candidate is using struct. This creates a struct that we can use to create candidates. It's kind of like a template for creating candidates. In this case, a candidate requires an ID, just one or two because I only have two candidates. A candidate also needs a name, and of course a vote count. Then, a public mapping, basically a list visible to everyone of voters, is created to store the accounts of voters, just to make sure nobody votes twice. This mapping is referenced later. Another public mapping is created, this time of candidates, which can be used to check what their properties are, their vote counts primarily. A public uint is created, just the number of candidates. After this, a voted event is created. This just signals the Ethereum virtual machine that someone has voted for a candidate. Now the election function. When this function is triggered, it adds two candidates to the election, Hillary Trump and Donald Clinton. Next, function addCandidate adds a candidate to the election if Bernie Sanders wants to run. This function is private, meaning only I can see and use it. AddCandidate takes one input, name. From there, it adds 1 to candidates count, uses that as a candidate ID, uses the input name as a name, and sets vote count to 0. Finally, the public function vote. This function is available to everyone. The function takes one input, candidate ID, requires that msg.sender, you, haven't voted already, requires that the candidate actually exists by making sure candidate ID is greater than 0 and less than or equal to candidates count. It then adds your account address to the mapping created earlier that stores a list of voters. The function then adds 1 to your selected candidate's vote count, and finally emits the event voted event to the Ethereum virtual machine so that the EVM knows someone has voted. There's obviously a lot more code, but this is just tests and some HTML and CSS. To run the dApp, first I'll navigate into the election folder, which has all of my code. Then I'll run truffle migrate -- reset, which resets whatever testing I've been doing. Now I'll use npm run dev to start the dApp. These are my candidates, Hillary Trump and Donald Clinton. I'll pick Donald Clinton because he's a Clinton, not a Trump, and click vote. Now MetaMask, a browser extension I use for transactions, kicks in to make me confirm I want to pay gas, just a transaction fee for the miners that make this work. And now Donald's vote count has increased by 1. I can't vote again with the same address. Ethereum is a really cool blockchain that enables developers to create dApps that can actually solve huge problems, pointing no fingers at the 2016 election. Through this technology, we are able to impact so many different industries, and I am really looking forward to using this technology to solve some huge problems.